Welcome to our midterm exam presentation in Information Management 2. Our case is a Spotify-style music streaming app where we'll discuss the background, the entity relationship diagram, and a normalized database in third normal form. To begin, let's move on to the background of the case scenario, which Charles will now explain.
For this video, we will walk you through the third normalization process of a dataset on a Spotify-style music streaming application where all users' activities such as playlist, song, album, artist, genre, and playback history are stored. Business rules. Before normalization, it is critical to understand the business logic. These rules act as the foundation for how we define relationships between data entities and justify each restructuring. First, a user can have multiple playlists. Second, a playlist can include multiple songs. Third, each song is by one artist but may belong to multiple genres. Fourth, the same song can appear in a different playlist. Fifth, playback history is tied to user, timestamp, and song. And sixth, artist and genre details should not be duplicated. These rules clearly define cardinalities such as one-to-many and many-to-many relationships, and guides how entities must be separated and linked across the database structure.
Now let's move on to the unnormalized form to 1NF transition summary. Multiple playlists can share the same name as long as the creation dates are different. Each record uniquely represents one playback event. The song is tied to a specific playlist and playback date. At this stage, all values are atomic and each row represents a single event. Next, let's move on to the transition from 1NF to 2NF. At this stage, we have isolated distinct entities with their own keys, remove partial dependencies which were the main source of data duplication, respected the business rules defining one-to-many and many-to-many relationships. This helps reduce redundancy and maintain data integrity across all entities.
Hello everyone. Today we will be presenting our entity relationship diagram for a Spotify-style music streaming app. Our ERD represents the structure of a Spotify-style music streaming application. It captures how users, songs, playlists, artists, albums, genres, and playback histories are connected. Now, let's go through the tables one by one and explain their entities, data flows, and relationships. The user table stores information such as a unique ID, username, and email. One user can create many playlists, but each playlist belongs to exactly one user. This makes the relationship between user and playlist a one-to-many relationship. Similarly, one user can also generate many playback history records, but each playback record belongs to only one user, making user to playback history another one-to-many relationship. The playlist table stores playlist details such as ID, name, and creation date. Each playlist is tied to a single user. Playlists are linked to songs, but since a playlist can have many songs and each song can appear in many playlists, this is a many-to-many relationship. To handle this, we introduce the playlist song table, which acts as a bridge between the playlist and song tables. Now, I'll hand this over to Miguel to discuss the song table.
The song table contains details such as ID, title, duration, and links to both an artist and an album. The relationship between artist and song is one-to-many, meaning one artist can create many songs, but each song is tied to only one artist. Similarly, the relationship between album and song is one-to-many, meaning one album can include multiple songs, but each song belongs to only one album. Songs are also connected to playlists through the playlist song table, and to genres to the song genre table, both forming many-to-many relationships. Finally, songs are tied to playback history, where one song can appear in many users' playback history, making the song to playback history relationship a one-to-many. The artist table stores details of musicians or bands. An artist can have multiple songs, but each song belongs to only one artist, which creates a one-to-many relationship. The album table stores album IDs and names. The relationship here is also one-to-many, meaning an album can contain multiple songs, but a song belongs to only one album.
The genre table stores categories of music such as pop, rock, or jazz. A song can belong to many genres. The genre can contain many songs. This many-to-many relationship is handled by the song genre table, which links to song and genres without duplicating data. The playlist song table contains playlist ID and song ID, and its role is to resolve the many-to-many relationship between playlist and songs. The song genre table contains song ID and genre ID, and its role to resolve the many-to-many relationship between song and genres. The playback history record user activity. Each record contains the user ID, song ID, the stream date, and whether the song was liked. The relationship here are straightforward. One user can have many playback records, and one song can appear in many playback records, meaning both are one-way to many relationships. Together, these entities and relationship model how a real music streaming platform works. User create playlists. Playlists connect to song belong to artist and album. Songs are classified into genres and user activity is tracked to playback history. This design ensures data is connected correctly, avoids duplication, and support flexible queries for a Spotify-style music streaming application.
Back again to the business rules. Starting with the first rule. A user can have multiple playlists. Second rule. A playlist can include multiple songs. Third rule. Each song is by one artist but may belong to multiple genres. Fourth rule. The same song can appear in different playlists. Fifth rule. Playback history is tied to user, timestamp, and song. Sixth and the last rule. Artist and genre details should not be duplicated. Here are the tables that are created to comply with the business rules. User table, playlist table, song table, artist table, genre table, song genre table, playlist song table, and playback history table.
We'll talk about them one by one, starting with the playlist table.
Following these business rules. Rule number 1 states that a user can have multiple playlists. So, we created a table that will provide us information about a playlist and the user who created the playlist. In addition to this, we also included the playlist create date and the playlist ID to avoid data redundancy and provide a detailed information for each playlist. And for clarity, we created a user table to provide the detailed information for each user.
Next up, we have the playlist song table. Now that we have a table to provide clear information about each playlist, we then created the playlist song table. We separated this table to the playlist table because according to the business rule number 2, a playlist can include multiple songs.
In addition to that, there is the fourth business rule. Multiple users might have an identical song to their own playlist. Should we include the song to the playlist table, then we will have the data redundancy and duplication.
So next, we have two connected business rules, number 3 and number 6. Each song is by one artist but may belong to multiple genres. But artists and genres details should not be duplicated. With the song table, we have the sufficient information for each song including its duration and album. But for clarification, we provided an artist table for each artist information, are connected, and completed the third business rule. Each song is by one artist, but how about each song belonging to multiple genres? Be advised that including genres which may have repeating values may cause data duplication or redundancy to the overall table. That is why we will have to separate it to another table. If you watched our previous video, we explained the purpose of the junction table, while the genre table explicitly identifies which song belongs to what genre. After this, we are now successfully followed the business rule 3 and 6.
Lastly, we have the playback history table, emerged from the business rule number 5. Playback history is tied to the user, timestamp, and song. This is pretty straightforward. We just compiled playback history, timestamp, and song to one table, but in addition to this, we included whether the table liked the song or not.
And that concludes our case study on a Spotify-style music streaming app. From the background scenario to the ERD, and finally to the normalized database in 3 and F. We've shown how proper database design reduces redundancy and ensures data integrity. This marks the completion of our midterm exam presentation in Information Management 2. Thank you for watching, and we hope you enjoyed our presentation.